Okay, so we are going to continue with lesson 5.6, which is the square of binomials, because we're going to look for perfect square trinomials within polynomials that have 4 terms. Okay, so this is going to require some thinking. It's going to require rearranging things. So you're really going to have to think about this. This is not the kind of thing that you can really memorize. You should memorize the different patterns, but this is something where you're just going to have to kind of think through it. Each one is going to be different. Okay, so let's look at this first example. Here we have 4 terms: x squared minus y squared plus 6y minus 9. Okay, notice that these two are perfect squares. I am subtracting, but then I've got this 6y here and I've got this minus 9, which don't really make a whole lot of sense. So let's do this. Since these two are y terms, I'm going to see if I can make this into a perfect square trinomial. So the first thing I'm going to do is I'm going to um, put it in parentheses. Okay, so I'm going to make this into one quantity and I'm going to subtract it. So what happens then is the sign of all of these is going to change. So if I'm subtracting, because I would have to distribute the negative, so I'm kind of doing it in reverse now. This would be y squared, this would be negative 6y, and this would be plus 9. If I distribute the negative, I get negative y squared plus 6y minus 9. Now, if I look at this, this could potentially be a perfect square trinomial. Y squared is a perfect square, 9 is a perfect square. So let's see what happens. If I take the square root of y squared, it gives me y. The square root of 9 is 3. If I do y times 3, that's 3y times 2 is 6y, which is what I have here. So that is a perfect square trinomial. So I can write that as y minus 3 squared. Now, this is a perfect square, this is a perfect square, and I'm finding the difference. So I have a perfect square, or I have the difference of 2 squares. So I take the square of the first one, and I'm going to do adding here, times the square of the second, which is y minus 3. Now I'm going to do subtraction, which means I have to distribute that negative. So if I write it like this first, and then I'm going to distribute the negative. So the x minus y plus 3. Now I factored it. But each of my factors, instead of being a binomial, is a trinomial, which happens sometimes. My x and y are different. So here I have x plus y minus 3. Here I have x minus y plus 3. And the reason it's a plus 3 is because I distributed the negative. Okay, so this is really 2 or 3 steps involved in this. Okay, so this is kind of the crux of factoring polynomials. Is it's not always going to be really cut and dry. You're going to have to look for it, and a lot of times you're going to have to factor several times. So let's look for what we're looking for is to see if we've got at least 2 perfect squares and if we're finding the difference. So here I have a perfect square, here I have a perfect square. I'm finding the difference here. I'm subtracting this perfect square. And if we notice, this right here looks like a perfect square trinomial. Perfect square, perfect square. Let's check it. The square root of u squared is u. Square root of 1 is 1. U times 1 is 1 times 2 is 2u. So the perfect square is there. So I have u minus 1, because this is a minus, squared. So that's this perfect square trinomial factored, minus v squared. Perfect square, I'm finding the difference. So again, it's the difference of 2 squares. The square root of the first one is u minus 1. The square root of the second one is v. So there's my first one. And then it's u minus 1 minus v. I don't have to worry about distributing a negative because this is what I'm subtracting. I'm only subtracting the one thing. So this is completely factored now. Okay, so when you have 4 terms, recognize that you could potentially end up with 2 trinomial factors. Okay, especially if you have 2 things that are being squared. All right, so now let's look at this one. We have x plus 1 squared minus 2x plus 1 plus 1. This is a trinomial, and it looks like a perfect square trinomial. Let's check it. The square root of x plus 1 squared is just x plus 1. The square root of 1 is just 1. If I multiply these together, x plus 1 times 1 is x plus 1 times 2 is 2 times x plus 1. So this is a perfect square trinomial. So it's the square root of the first one, which is x plus 1, the square root of the second one, which is 1, and I'm actually subtracting them, and the whole thing squared. So x plus 1 minus 1 is equal to x squared. So this whole thing factors just to x squared. So let's see if we can figure out, let's check it. We're going to check it by plugging in a number. And I'm going to pick the number 3. So if x is equal to 3, then this whole thing should be equal to 9, right? This whole thing would equal 9. So 3 plus 1 is 4. 4 squared is 16. 3 plus 1 is 4. 2 times 4 is 8. So it would be minus 8 plus 1. 16 minus 8 is 8 plus 1 is 9. So this is correct. Okay. So if you get something like this and you're like, wow, I'm not really sure, pick a number and pick a small number. Okay. 2, I prefer to pick 3. And see if it works, and it works. So this was a perfect square trinomial, but because we have these quantities in parentheses, as long as they're the same, okay, you're good. All right, let's look at example 4. These are fun. So this one says solve. So now I've got an equation. This whole thing is squared. This whole thing is squared. So they're both perfect squares, and I'm subtracting. So this is the difference of two squares. So if I were going to write this, remember if I have something like this, a squared minus b squared, I write it like this. It's going to factor like that. Okay, so this, I can do the same thing here. So I have x plus 2, because that's the square root, plus x minus 3 times x plus 2 minus, and I'm going to put this one in parentheses now, x minus 3 equals 35. So I have 2x minus 1 times, this will be x minus x, the x's cancel. This will become a plus 3. So 2 plus 3 is 5 equals 35. Well, now I can use the distributive property. I'm just going to rewrite it like this. If I use the distributive property, I have 10x minus 5 equals 35. So 10x equals 40, and x is equal to 4. Let's try that. 4 plus 2 is 6. 6 squared is 36. 4 minus 3 is 1. 1 squared is 1. And 36 minus 1 is equal to 35. Okay, so it checked. So if you get an answer and you're like, this one, it's kind of obvious because it's a nice integer. Plug it in and make sure it works. All right, let's look at example 5. Perfect square, perfect square, perfect square. However, I'm not subtracting, so this is not the difference of two squares. But if I were to subtract one of these over here, it would be the difference of two squares. So let's just pick one. I'm going to go ahead and pick this one. So this is going to be 3x plus 2 squared is equal to 5x minus 1 squared minus 4x minus 3 squared. This is just, if we go ahead and multiply this out, it's going to be the first one squared, so 9x squared. 3x times 2 is 6x times 2 is 12x, plus 4. So I've just multiplied that out. This one, again, is going to be difference of two squares, so this might take a little bit. So I have 5x minus 1 plus 4x minus 3 times 5x minus 1 minus 4x minus 3. And again, I have to put that in parentheses so I can distribute the negative. This just stays 9x squared plus 12x plus 4. I got to simplify this whole side first. So 5x plus 4x is 9x, and negative 1 plus negative 3 is negative 4. And 5x minus 4x is just x. And then this becomes a plus 3, negative 1 plus 3, so it's plus 2. All right. 9x squared plus 12x plus 4 equals. Now I'm going to use FOIL here. So this is going to give me 9x squared, which is nice because those will cancel out then. So I have a feeling I'm on the right track. 2 times 9 is 18. So this would be 18x minus 4x is going to be 14x minus 8. So these cancel out. And I'm going to go ahead and subtract 14x on each side. I'm going to subtract 4 on each side. And I get negative 2x is equal to negative 12. So x is equal to 6. So let's check this. 3 times 6 is 18, plus 2 is 20. 20 squared is 400. 4 times 6 is 24, minus 3 is 21, and 21 squared, this is where the calculator comes in handy, is 441. 5 times 6 is 30, minus 1 is 29, and 29 squared is 841, and I can see if I add these together, I get 841, so it worked. All right, so our try this then is we're going to factor. And I notice that I have difference of two squares. I notice that this is possibly a perfect square trinomial, except this is negative. If I put it in parentheses, it's going to change the sign of each. Okay, so this now becomes a perfect square trinomial. So it would be b minus 3 squared. B squared, 9 squared, negative 3 squared is 9. B times negative 3 times 2 is negative 6b. Okay. Then now it's the difference of two squares, so I have a plus b minus 3 and a minus b minus 3. So a plus b minus 3. And if I simplify this, it's a minus b plus 3. So that's that factor.